Thank you everyone for joining in this virtual chat. My name is Francesca. I'm the Chief Innovation Officer at TG0. We are a small startup that is based in London, and we mainly develop touch sensing technologies, but for a range of different industries. So we cover some automotive, gaming, some aerospace, and more generally consumer products. I'm here today to talk about the future of tactile interfaces and tactile technologies, and I'll be talking mainly from the point of view of touch sensing and actually integration of new and different types of materials in this area. My role has quite a fancy name, but really comes down to kind of developing R&D within the company. If you have any questions that you want to kind of like discuss later, please put them down in here. We'll try to kind of scroll back, and it's a bit hard for me to multitask on looking at the questions now, but we can come back to them later for sure. So let's get started with what we actually all think that tactility or tactile interfaces are. The literature on these types of technologies is quite extensive, but really what I want us all to think about now is to think about mixing technologies and the sense of touch, and what is the role of the sense of touch in technologies. And if you look from just a perspective of how the sense of touch is broken down when it is described, there are tactile sensations, which are the ones that are generally related to the sensations that we feel on our skin, such as texture, contact, or pressure, and kinesthetic sensations, which are more related to how we actually move in the space, how we perceive our body. And I think in this specific scenario, how we actually interact with objects in space. And I think that both are actually quite important, even though we kind of mainly cover tactile and not kinesthetic, but they both kind of relate to how we deal with the world, we understand the world around us. But when we start looking, when we start thinking actually what are the type of devices and interfaces that include touch that we interact with on a daily basis, they pretty much look like the one that you see on screen in here. They look like flat slabs of glass that you can either zoom in, zoom out on, or kind of move your finger around. And that is pretty much it in most of the cases as of nowadays. I wonder if any of you know actually why this is the case, why we interact with this type of devices and interfaces. And that is really, in many cases, come down to one single material that maybe you know about, which is ITO, which is a superconductive material, well, a conductive material that is also transparent and can be applied to basically any type or most types of flat surfaces. But it has a massive limitation, which is that actually, if you were creating a bendable structure with this material, it would crack. And that limitation has actually shaped our current technologies. And we interact with the world, and this material has basically shaped the way in which we interact with the world nowadays. I wonder if you guys agree or not with it. But I don't think that it has just shaped the present of the kind of touch interfaces we interact with, but it has also shaped our imagination of what the future looks like. And that is, and this is taken, this sentence is taken from an article that I read a few weeks ago when I was preparing this talk, and I found quite funny. It's actually quite an old article, but I think it's still, it's still standing in a sense that we actually keep imagining the future of technologies and of like what is currently around us or in the future will be around us as massive touch screens. And the point that I want to make here is that actually all of these touch screens, they mainly rely on actually your vision to be able to interact with them. There is not that much tactile information that you can actually use. And this is kind of missing out on a major part of how humans have been for ages interacting with the world. So I'm questioning, I guess, and maybe all of us in the field are questioning, is this what good design is? And at TG0, we really believe that good design and tactile interfaces should look more like this in the terms of being more three-dimensional, more textural, more intuitive to use from the point of view of how you can actually interact them with your hands and use them, and actually more fun to use than just sliding your finger on a piece of glass, I guess. And I'm coming back to this point that I've actually seen in another presentation today, that in our company, but this is more broadly for the industry really, designers are coming into the spaces of technologies, and we are mainly designers in our company. And we are kind of we're asked to rethink the way in which we look at technologies and look at putting actually the human at the center. And instead of fitting the way in which humans interact to the current technologies that are available, we are trying to go the other way around and actually creating devices that are intuitive for a richer human experience. And we are seeing a lot more of these popping out, I guess, because designers are having kind of like that input in technology that wasn't possible before. So one of the ways in which we ask some questions when we try to rethink our relationship to technologies in the space of touch sensing and tactiles is really looking at some fundamental questions, like what can materials do from us? And I go back to the idea of ITO and how that has shaped the way in which we work with technologies. And what is really happening now, which I think is extremely exciting, and I would like to hear about what you guys think on the chat actually, is that there is a renaissance of material science that is allowing us to actually start embedding certain material properties into materials that have always not being the go-to materials for developing interfaces. And I'm talking about, we work, for example, with plastics. I think foams are quite exciting. Any material that is kind of stretchable, that is conformable. I think these are coming way more into the technology space. And this is what I think is gonna partly shape the future of this sector and of products too, because we have opportunity to actually embed new properties and functionalities in materials. And from our particular perspective, we work with conductive materials and embedding conductive properties into materials and using them as sensors. So this to me is really one of the key enablers. And I think that soft materials will be quite important in the future. On the side of this, I think we probably all agree with this, that there is kind of a shift in the relationship between hardware and software development. And I'm going to talk a little bit more about what I mean with this, which is we have had the tendency in terms of technology to kind of continue developing from a hardware perspective, more accurate, more reliable, more miniaturized technologies in order to kind of create better and more functional devices. But what is actually happening now that is quite exciting and interesting is that we can take some of that pressure off hardware now and we can move it onto software, because we have tools that are allowing us to kind of gather data and analyze data in a completely new way, or in a very accurate way. And I think what is pretty exciting, and this is something that we do quite a lot in our company too, is to kind of like bounce back and forth between hardware and software, and to kind of like use software to bring a prototype to a certain level, and then ask the question, what is software missing? And then going back to the material phase and kind of asking, okay, how can we improve the properties of this material in order to gather more excited information from that material? And I think this is something that is kind of happening a bit everywhere. There is more of an integrating approach to the two, or I believe that that's where the pinnacle of what we can develop in the future will come through. Moving one step further, what I think that is pretty exciting is that when we are using tools such as advanced signal processing and machine learning on the devices that we are developing, we can move from kind of like the more simple layers of understanding what a material does for us, understanding a certain signal and turning into a touch sensing, into actually being able to describe complex gestures or even abstract things in space and understand how our hands are moving. And this is just, I'm talking about this because this is actually something that we have developed. So what I want to show you with these images is actually our first consumer product, and I don't want to talk about it from the point of view of trying to sell it to you. What I'm trying to say is that what we have looked into is actually applying all of these principles that I was talking about, which are, first of all, kind of an ergonomic design. And we have taken a piece of material, simple plastics, and kind of designed it in a shape that can be easily wrapped around our hand. But then what is actually turning this product into kind of these magical interactions that I talked about in the previous slide is that we have all of these tools to kind of record accurately how our hand is moving when it's wrapped around this device. And this is allowing us to kind of describe mostly all of the kind of like finger possibilities of finger movements around this device. Another example that I want to talk about is another project that we have developed. And this, again, is from the point of view of the approach. So I mentioned before that I believe the soft and conformable materials will actually take huge part of what the future of interfaces and tactile touch interfaces is because we're seeing that these materials that are kind of entering this space, they could be used as large-scale sensors. You would never sit down on a touch screen, but you would sit on or walk onto a piece of foam and trying to understand how to use this type of materials to develop new technologies. And in this case, we work really trying to create a large-scale touch and pressure sensing device. I can see that there is a question in there. If you don't mind, I'm gonna take it later. I'm gonna call you on stage. So we really looked at how we can use a simplicity of construction and use 3 simple layers of material to create a sensing device. And from developing the sensing technology, then we looked into the layers of software that can be applied. And again, this is just an example. When we're using conformable materials, things that kind of wrap around our bodies, there is a lot of information there that we can use to understand, to basically describe gestures, but also to understand user behavior. So in this case, I don't know if you're seeing in here, for example, Victor, that is on screen, is fidgeting with his leg. And this can be an indication of, for example, whether he is particularly stressed under in a particular moment in time. And this is kind of information that we can obtain and we can analyze from through applying machine learning or from applying complex signal analysis to devices. So my final point in talking about the future is not about the interactions and the experiences, but it's also about how taking a new approach to materials that is not focused on necessarily miniaturization, but is focused on kind of like simplifying hardware and creating more of a linear approach between the two, actually brings some other benefits. So we are seeing that by taking this approach, for example, we can actually save manufacturing costs and we can save assembly costs compared to more traditional devices. And I think what is actually more exciting than that is that if the whole industry, I believe the whole industry is kind of like turning a bit their back onto all of these very complex constructions. And this is quite exciting because when we take more of a monomaterial approach, we actually have better opportunities for sustainability and for being able to recycle in different technical cycles the materials that we're actually using in the devices. So I don't know if I've been able to grab your attention for the full 15 minutes. I guess the main points that I wanted to make in this presentation is that I believe that currently the touch interfaces that we interact with on a daily basis are pretty actually not tactile and not very exciting. That conformable and smart materials will become key enablers for the development of future tactile interfaces, and that the combination of these new materials together with software tools, advanced software tools, will actually allow us to understand and predict user behaviors, and therefore to create more exciting and intuitive user experiences. So I'm just gonna leave my details here on screen in case you wanna you want to take our details, and yeah, I'm open to any questions. I can see that Emily wants to join on screen. Let me see if I'm actually able to. Oh, Emily? So I didn't manage to include Emily's. So any questions? Okay, I can see a question here. How soon can we expect a revolution in the way interface technologies are being built? This is a good question. So I can answer from the point of view, for example, of conductive materials. There is quite a lot of work, mainly at lab scale still, with new materials such as graphene. And what is actually happening now is that there is a lot of funding to kind of understand how we can integrate these materials and kind of bring them up to scale. So I think there are still some challenges in there, even when we talk about soft, transparent sensing interfaces, for example. So I don't think it's something that we are going to see tomorrow, but at the same time, the kind of like development, let's say the development phase is becoming much faster. So definitely in between the next five years, we're going to see something exciting. But I think one of the questions here is really, what are the killer applications for tactile technologies? Because in a way, the smart screen, right, like at the moment, is kind of answering our questions in that specific consumer space. But I think VR is probably going to push quite a lot our kind of understanding and kind of like consumer requests for products that are more kind of like that understand your body in a different way and you can interact with in a three-dimensional space. Did you have any projects in education, touchscreen programs for children? So no, we don't have at the moment. It's something that it is definitely possible. Let's say that we actually work a lot with like we're trying to push the technology to industries such as automotive and gaming industries, but it is possible to create this type of applications. I think there are already quite a few companies that are doing this in the touch sensing space with different types of materials. So that's also something that was kind of like stayed away from until now. Do you expect a pushback from society due to the current campaign against plastics? That's a good question from the material perspective. I think, so I'm gonna say something that maybe I shouldn't say. I don't think plastics is inherently bad in terms of being used and then being able to reuse it. I think the main challenge that we have with plastics is that we create throwaway devices with it. So we're kind of like filling the oceans with plastic bottles that can actually be used and reused to create products. So Definitely what we're seeing is that there is a lot of focus on bioplastics, but again, is the same challenge as developing new technical materials from the sensing or conductive perspective, is that these materials are not that stable yet to create very long-term use products. So we're definitely going to see a lot happening in the space of biocomposite and biomaterials that have conductive properties and can be used in sensors and even actuators. And there's quite a lot in the literature already. So scientists are really already looking in that direction. What is the biggest obstacle to implement it on small devices such as a smartwatch or mobile phone? I think this is an interesting question. What we always answer when a new project is coming in is what is the level of accuracy that is required. So when we're looking at things like zooming in and zooming out, that's pretty straightforward to develop. We're also looking at small scale touch sensing, like cursor type of interactions, and that is also possible. What is quite interesting is that depending on the form factor, so depending on whether you have a circular interface or a squared interface, the approach really changes, and this is something quite fascinating as well as with the scale. So we always try to look the minimum amount of kind of like discrete separate layers of materials, and we've been successful with it so far, and we're moving into kind of increasing the level of complexities of what we can achieve. I hope that answered the question off. Any other questions that I might have missed? You can pin them again. I can see one from Caroline. When will we see first applied on a bigger scale for normal consumer? I guess I kind of answered that question before. I actually have a question for you guys, which is coming to this talk, what was the picture in your head of what will be the future of tactile interfaces? Where do you see, what type of devices do you see? Do you see it in consumer products, or do you see it more embedding in kind of like smart homes or into the automotive sectors? I think there are so many different ways in which this can come into being, but as I mentioned before, I guess we're all looking for that killer application for it. Jacinta is asking, smart devices for visually impaired people, is that a near or longer future? I think that is in the near future. I think it depends on what you mean, because obviously for the visually impaired, you have devices that have kind of like a textural feedback. So there have been quite a lot of work onto whether you can create surfaces that kind of create bumpy feelings under the fingers. That is quite complex. And I think what this question brings in is also the question whether is touch the most effective technology for that application, or something like voice recognition. Is it something that is more applicable for that because it's the requirements from a hardware perspective are much more limited. Also in remote work and tools for remote tactile interfaces for surgeries, remote maintenance, from Patrick. Yeah, definitely. I think this is the go-to field for like fully embedded tactile sensing and actuating devices. Training for surgery is definitely one of the main fields, together with robotics. So far we haven't actually worked on any project that required both sensing and actuating, but that is definitely an area of interest for us, and I guess for anyone that is working in this field. So Jacinto also says, I'm biased because I work on embedding sensors, but I think touchscreens will be everywhere. Yes, that's true. Touchscreens are everywhere and will be everywhere, but I want to challenge this thinking and also ask, do you think that touchscreens will be replaced completely or at some point with VR, that VR will just become, well, they are screens in a way, but kind of like a different type of screen. Sensor screen. Okay, Matteo Rossetti says, definitely excited for the game and VR space. Yeah, absolutely. We have, this is also why with our technology, we've kind of target that market with like our first consumer product, because we see a lot of opportunities in there, and not just for a hand type of interaction, but maybe more in the future with full body interactions. We also believe that field in itself should grow a bit more and show us some more potential to understand where to go in that direction. Any more questions? In case there are not more questions, or if you later in the day you might want to learn a bit more about what we're doing, or you want to discuss something, we have actually an exhibitor booth, so you can find us there. So if you scroll up on the top of this chat, you will find a link to it, but it's also easy to find on the exhibitors space. So thank you guys for joining.